Hello, welcome. I'm Richard Okoth. This week we have been building survival analysis model, which is essential for predicting futures performance of developers. What we did throughout the week, first was to load the data developer data set. Then we did data processing, especially we processed time to complete, where we created a feature called time and was based on implement, where we used various metrics to measure completeness of tasks, to fill metrics using the maximum of those metrics to measure up to complete. And then we also created correctness indicators, whereby to determine correct each of the all the correctness indicators were marked yes, and that one we use the boolean. We created a boolean variable, then converted it to a binary using just changing the type to integers. Then we separated the data into two groups, the first one being the control group and the next one treatment. Then we fitted Kaplan-Meier filter by creating instance of Kaplan-Meier filter. Then we computed the survival probability for the control and called the table using survival function. We did the same to treatment. Then we combined it to a data frame, a table. Then we plotted the Kaplan-Meier survival curve, and we used two approaches in plotting. One, we plotted it from the table created from the values we computed, and the next approach we use plot survival function to plot the same. Then the results we got from the plot, we evaluated it by testing the significance using the Lagrange test, and then the same we fitted the Cox proportional hazard model to the data, and we did two plots. First, we plotted for time, correctness, and the group alone. Then after another plot, now we added predictors. And the one we added predictors, we added method and solution, the two, and that is what we got. Now, from what we have done, this is a summary of our findings. Based on the Kaplan-Meier curves plotted, we can see there is a difference between the two difference in performance of the two developers where the treatment group is lower. This implies the same they take so they display better performance since they take a short time to complete the task correctly. Then the same can be seen in the second plot plotted using plot survival function. Then on the log rank test, since the results from Kaplan-Meier curve was showing that there is a difference between the two groups where the treatment was displaying a better performance. We performed also the log rank to see if the performance was significant. As based on the p-value we are getting a p-value of 0.39, which was greater than the significance level, that is 0.05, and therefore this displays that there is the difference is not statistically significant. And after fitting the Cox model, let me take you back to after fitting the Cox model after fitting the Cox model, after fitting the Cox model, after fitting the Cox model, we find the hazard ratio of 1.86, and this implies that the treatment group treatment is 1.8 times has is a 1.8 times higher chance than the control group, and therefore this also shows that the treatment developers in the treatment groups perform better. However, if we check now the significance of the result, the p-value is 0.04. We can see it is greater than the than the significance level at 95%, and therefore the difference is not statistically significant. And the t-test, the log rank and Cox model shows a consistent result, and that there is a difference. They are telling us that the difference is not significant. So one of the limitations of this analysis can be attributed to quality of the data. We see our data set is small, and this can cause problems on the representative. We cannot make it cannot be used to infer, or we cannot be used to infer based on the small size, and also one of the it shows that now from the KM curve we saw point they are crossing, so that one can point to a violation of Cox proportional as assumptions of constant ratio, and that is why we can see as much as difference is there, and based on the sample size which is small, we cannot see the difference, a significant difference, because also the sample size determines the power of the test. Thank you.